Thank you. And one more thing, some shameless self-plug before we start with the actual presentation. So I'm also part of a team of 5 people who organizes a conference in Germany, in Cologne to be precise. And especially after seeing Adrian's talk today, and as I mentioned, I actually wanted to get more in touch with the developer scene in Eastern Europe. So we have a call for papers. We pay for basically everything. So I bet some of you have some good ideas what to talk about, and I would like to kindly invite you to send out a paper if you have a good idea and want to talk about and, well, want to come to Cologne in September. Okay, enough with shameless self-plugs, etc. So actually this talk was called Oh My IoT, but for me that wasn't dark enough because I'm in that IoT space, more to be more precise, in the smart home part of it for nearly 5 years, and Oh My IoT wasn't dark enough. So it's actually a lot of horror stories I want to share, and therefore this talk is called Tales from the Crypt. So, fair warning, this is not the talk you will see a lot of code. So you probably will hear me ranting for 30 minutes, and then we'll have like 15 minutes of Node.js because we are at JSCamp. In case you do not know yet, on Twitter I'm AskAdisco, as well as on GitHub. If you don't use Twitter, GitHub, whatever, you can write a mail at public@askadisco.com in case you have some questions after the talk. So yeah, as said, for nearly 5 years I work for this project here. It's a project from Deutsche Telekom, in which we're building a smart home platform. So we want to unify all those different protocols and vendors, and we actually want to get stuff working together. So this is where I mostly got my experience from, although I have some fun time with hardware hacking in my spare time, so I won't be talking about the product KiwiCon at all, and this will be the last time you hear me saying that in this talk. But working for this project, I don't want to say that I'm biased, but I'm biased in one regard, because I think that the current state of home automation and the smart home sucks. You will understand why when we're done. And I've actually had a hard time finding a positive entry into this presentation. And therefore, I'm gone with my feelings, and I'll do the bad introduction, not the good one, I'd say. But first things first, what is the Internet of Things? So I'd say the Internet of Things is a bullshit buzzword made up probably by some smart people and then abused by some managers. I call it bullshit. Nobody, no developer I asked, hey, I'm not even asking the question, hey, do you work in the IoT space? No. Nobody does that. That's a management bullshit buzzword. Sorry. So, and also, I mean, like, we connected devices before that. IoT was a thing. We had smartphones. In the consumer space, we had Apple TV, TiVo, whatever. Well, we had computers in general connected via the internet with each other. I mean, a computer is a thing, isn't it? And all those little things aren't much different from being a computer. But yeah, so I checked in Google News, so sorry that's in German, but I looked up the term Internet of Things and when it got popular, and it seems like, yeah, there was some slight boost 2011, but in the year 2013 and 2014, it kind of exploded. So everybody was talking IoT, and therefore I'd say, let's treat it every time you hear it as a management bullshit marketing buzzword. IoT is, to me, it's a dead term. But why did it explode so much in the past, let's say, 3 years? Because computers in general were getting a lot cheaper than they were before. They're getting faster. They're getting smaller. And what's most interesting in the space of connected devices is they are consuming less and less power. If you check out the latest Raspberry Pi, the Raspberry Pi Zero, which like could fit like in my hand and consumes 0.35 watts under heavy load, something like this, that's amazing. And compare that to your desktop PCs in the early 2000 years, where like desktop towers that were consuming, I don't know, 200 watts at least. And also, the internet is getting, or has been getting, cheaper, faster, a lot faster, widely available. Well, fun fact, the village where I'm from in Germany still doesn't have broadband internet and still doesn't have a proper cell phone connection. So there it isn't available. But in general, we can consider it as being widely available. And also thanks to flat rates and being cheap, not being charged per megabyte transfer, we can say the internet is always on. I mean, like, I work for a telecommunications company, except when it's not. I mean, like, and those are the main reasons that we had a lot of developers, engineers, and also managers just saying, yeah, let's connect all the things. No matter how stupid they are, let's just connect them and see what happens. But yeah, today we will not talk about mostly Raspberry or stuff like that. No, we will focus on smart home and more or less like products you can actually buy that exists in the consumer space and some do-it-yourself space as well. But first, when we have to talk about wireless smart home, we have to talk about what I call protocol madness. Because it's not like that one IoT or smart home protocol, no. The most prominent and most used ones are Homematic, which is actually called Bitcos, which is, in fact, the most widely used protocol in Europe, even though it's only available in Germany, Austria, and Switzerland. But they sell a lot of devices in those three countries, and therefore it's Europe's most popular thing. Right next after it comes Zigbee. If you ever heard of Philips Hue light bulbs, those wonderful LED light bulbs you can control with your cell phone, they are powered by the Zigbee technology or the Zigbee protocol. Well, to be fair, by one of the 12 or 13, they made a new one up, sub-protocols. So actually they can talk two different sub-protocols, Zigbee Home Automation and Zigbee Light Link, but that's going too deep already. Yeah. Also, there's Z-Wave or Z-Wave, depends on where you are in the world. And that is quite close to Zigbee, but it's driven not just by one big company that licenses it. There's also an Ocean. Actually, that's an Ocean product. An Ocean is an interesting protocol in that regard, that the products that have the Ocean chip should be generating the power for transmitting the data on their own without being plugged into any power source or having batteries. So this switch here has no batteries. It generates the energy it needs to send the data from the kinetic click. So it's like, you hear it? Quite loud, but it's generating the energy for the data to be sent. That's actually pretty cool, but also has some flaws I will go into deeper later on. Also, of course, there's Wi-Fi, which is not so good for battery-powered devices, Bluetooth, and you can go on and go on. In the end, it's like that well-known XKCD with the competing standards. There's always a new one. Recently, Google introduced Thread as a protocol. Well, actually, that's not a totally new protocol. It's actually like the 14th sub-variant of Zigbee. But who else? Companies just like make those protocols up. Like you have a new one every month. But the protocols that are widely used are Bitcos, Z-Wave, Zigbee, also in Ocean. And we'll focus on that. They are in the so-called ISM frequencies range. So they're allowed to be used in industrial, scientific, and medical applications. And in Europe, they'll send on 868 megahertz, at least because Z-Wave and Zigbee. Well, Zigbee can as well send on a 2.4 gigahertz network like Wi-Fi does, but most of the Zigbee products stick to this frequency. The problem is that outside of Europe, for example, Z-Wave, Zigbee, and an ocean standard needs to use the frequency of 915 megahertz. This is because of legal restrictions and whatever. I'm fairly sure that in South America it's the same 915 megahertz. I know in Japan, for example, it's neither 868 megahertz nor 915 megahertz, something completely different. But in the end, that means I buy a light switch in, let's say, in the US. I'll bring it a Z-Wave light switch. I'll bring it to my already enabled Z-Wave network at home, and it doesn't work. It's the same protocol, but it's a different frequency. Also, most of these protocols, some of these protocols use star topologies. So that, for example, is what an ocean and Bitcos do. So you have one central access point. Z-Wave and Zigbee, they build mesh networks. So they have a fairly wider range where devices can communicate because they can use single devices as nodes and then distribute the messages throughout that mesh. Yeah, as said, for nearly all of that devices, except you have already a Wi-Fi router at home, you need something like a router that's also, some vendors call it bridge, some vendors call it coordinator. And that actually also means that devices like this, well, spoiler, they aren't connected to the internet at all. So most of the time, when we talk about the smart home market, we don't talk about the Internet of Things at all. It's more like an intranet of things, because those devices are connected with each other and with one coordinator, and that one is actually connected to the internet or connected to your Wi-Fi router, and actually acts as the gateway to the internet itself. So most of the time, it would be even like better to say it's the intranet of things, but nobody does that anyways. Why is this? Of course, energy reasons. I mean, like, you can't connect this thing that produces the energy on a kinetic press with a Wi-Fi chip because it's just too much, it consumes too much power. So mostly energy reasons are the reason for, or needing too much energy is the reason for not having a Wi-Fi chip built into these devices. The problem is that this protocol madness leads to this. Like, that is just a screenshot from my phone. I have this. That's actually an old screenshot. I'm now at 3 full pages of apps of connected devices because I have my Amazon Echo and my Philips Hue and some other stuff. And the problem is that this is not the Internet of Things. This is actually the iPhone apps of things or whatever. I mean, like, most of these apps, they don't have a browser equivalent. So that's not what I consider the internet. So a lot of vendors just say, yeah, I'm sorry for the strong language, but fuck the browsers, fuck anyone who doesn't have an iPhone or an Android device, because you need to have an iPhone, an iOS or an Android device to participate in this shiny new world. And no, that I personally totally disagree with needing an app for everything. That's bullshit. Also, the problem is you don't have interoperability between the devices. That means, like, I have a plug here from the vendor that uses the Bitcos protocol. I have a switch from an ocean here. And, well, usually they can't work together. So I can't turn on the light bulb with the switch. It's not possible because different protocols, different applications, and there's no bridge in between that is provided by the companies themselves. They just say, yeah, fuck you, deal with it. Yeah, nice. I want to buy everything from just one vendor because most probably they build the best device in every category. No, they don't. And it gets even weirder. So European regulations, as well as, I mean, like I'm from Germany, so we have another weird regulation that nowadays, if you have a smoke detector, the battery must last for 10 years. So you shouldn't have to change the battery like in 10 years. And that is a big problem if you have a connected smoke detector, for example, because also this battery needs to last for 10 years. But it's not only restricted to the functionality of giving an audio signal when it detects fire, it also needs to send up messages and have a tiny computer inside that actually builds up those messages. And that makes it even harder to build those connected devices because you have that restrictions. Also, in Europe, at 868 megahertz, every device gets only 36 seconds of airtime per hour. That means if I turn that switch on and off often enough, I reach that limit of having of 36 seconds of airtime that it gets per hour, and I can't control it anymore, because then the so-called duty cycle kicks in, and I can't steer it for, let's say, the remaining 40 minutes of that hour, because that's part of the regulation, and that's baked into every vendor that operates at 868 megahertz. Yeah. So basically, if your smoke detector has sent too many messages in 1 hour and goes offline after 40 minutes and then a fire breaks loose, well, you're the unlucky one because you don't get a wonderful push notification your house is on fire. No, because the smoke detector isn't allowed to send anymore because it already reached its airtime. Well, to be fair, the vendors build smoke detectors in a way that this won't be happening. But yeah, I hope you get my point. That's ridiculous with those 36 seconds of airtime. But it's not only all those weird restrictions and vendors and stuff. We have to talk about security and privacy as well. And I'd have to say it's probably as bad as you would imagine after I've seen all that protocol madness and regulations and stuff. It is really bad. So there's basically plain text or plain binary everywhere. So because Zigbee, Z-Wave, and Ocean, for most used protocols worldwide, are not encrypted by default. The spec says, yeah, we support encryption, but that's like an opt-in feature. So this one here, no encryption, just like I press a button, data over the air, anyone who can sniff at that frequency basically can read it. And the number 5% of devices overall that support encryption is actually from 2014. So the number increased a bit, but I'm not sure in which degree. So 5%, keep in mind that's from 2014, and it got better. You might ask, well, isn't there some kind of security baked into devices? Yes, so at least Bitcause and Z-Wave and Zigbee, you can activate key signing, 128-bit AES key signing. So basically that nobody else can just like tab into your network and steer your devices. They are still able to read the data, so what your thermostat says, what's your current temperature, but they're not been able to change the temperature. Unless they have sniffed the key at the initial pairing phase of that device. But that's a totally different story. The problem is with that key, it affects latency. So normally it's just like you send a request to the device, please turn on. The device says, yes, I'm turned on. But with the key signing enabled, there's one more hop to do. So it's like, hey, could you please turn on? And it's like, yes, what's the key? Here's the key. OK, I'm turned on. And that affects the latency of devices. So you feel it when it's not instantly, the bulb, the light bulb, for example, is not instantly turning on when you press the button. You feel that slight delay. Also affects battery lifetime. Again, not all devices support it. And, well, it's not encryption. It's just key signing. So everybody else can sniff the data. They just can steal your devices. Why? Well, battery lifetime. And battery lifetime. And, well, to some degree, also users and companies that just don't care. They just throw out products on the market, and they don't care about that particular thing. And a lot of users who, well, get their light bulbs at home, they don't care either. That enables us to, I'd say, one thing I'd like to try in the future, which I call drive-by heating, like sniff for open networks and turn on the heating system in the houses like very high. So that's like my thing I want to do instead of just Wi-Fi sniffing and driving around, drive-by heating. So, but if you're concerned about its security, blah blah blah, I'd say, to be honest, I don't think that any burglars will just like sit with a laptop in front of your house and just like, oh, I'm right next to opening the smart lock. Yeah. No. To be honest, I think they will just like take a stone or whatever and crash your window and get in and get the stuff out. I mean, like, that's the realistic option. Yeah. The thing you should be actually concerned of is, so it's not security, even if it looks extremely bad, but it's privacy. Yeah. So if we take the popular Philips Hue bulbs, what possibly could Philips as a vendor know about me when I got some Philips light bulbs? I'm not saying they do that. I'm saying they could get those data. So basically, they know when you're home or when you're not. So they use the geofencing feature to turn on the lights when you arrive at home, to turn them off when you're not at home. So also, thanks to this feature, they know where you live. And also, based on the fact if your bulbs are turned on or off, depending what time is it where you live, and if you're at home or not, they could probably like get out of this data if you're sleeping or not. Also, they might probably know the size of your flat or your house, or at least can estimate it, because most of the time you have more than one bulb. I mean, the starter kit comes for free. Let's say you have one in the kitchen, one in the living room, and one in the hallway. And then you have that bridge or that coordinator, well, let's say in your office. And all that devices have then a different RSSI, so a different signal strength indication. And then, basically, with the more devices you have and the more data you get about the signal strength, you can estimate how large the area is where the devices are placed in. Also, I'm extremely 99% sure Philips doesn't do that, because that was an experiment from 2 MIT students like 2 years ago. They used Zigbee to track people's movements throughout walls. So that's really interesting. You actually, behind the wall, there was one device that sent transmitting data over the Zigbee protocol, and there was another device in another room, and they could actually make up shapes of people who were behind that wall because of that. I don't know, that's like too sciencey for me, but extremely cool. But yeah, I mean, like, look at this list. That's just a light bulb. Well, it's just a light bulb. if we now think of Wi-Fi cameras at home, always an audio capture, like hello Samsung TVs, wearable tracking devices, logic that is not in your home, so all the data gets transmitted onto someone else's computer, better known as the cloud nowadays. I don't know, it's like this tickling feeling when I talk about it, because I have a lot of these devices in my home, and probably because I work with them, and there are probably a lot of vendors that have a lot of data about me, and I don't even know it. So, quick history fact. The Stasi was actually never officially existing. It was in Eastern Germany during the time where the communist regime was on in Eastern Germany. And the thing with the Stasi was they paid regular people like neighbors to spy on their neighbors, and if they were doing something critical to the regime, they actually should, well, sell them to the regime. And if they had all those possibilities with the smart home devices we have nowadays, probably in the old democratic, in the old communistic German part, they would have had the best and most luxury flats and houses ever, because the Stasi would have installed like every one of that devices into people's homes, because then they would have had full control over everyone. Well, yeah. That would be the government owning data. But hey, nowadays it's not the government, or not just the government owning that data. It's companies that own that data. And what do companies do? They make money. And what is it with money? Well, if you talk about money, and the more you talk about money, no, the more money you have, or the more money the talk is about, it gets even more dangerous. So I actually have even a much worse feeling when it comes down to that companies have my data and not the government, because to some degree I trust my government, but some company from, I don't know, China or whatever, not to blame any country, but that just collects my data, I don't have that level of trust in that company like I have in my government. So what I'm saying, well, strong language again, but yeah, I don't know. We're fucked, huh? It's that easy. So what should we do? Back to do-it-yourself stuff? Should we like get rid of all those shiny things and start building it up on our own using Arduinos and Raspberry and whatever? Well, I don't know. Every time I work with something that has more than 12 volts, I'm not an electrician, and I once ended up in the emergency because of working with 230 volts. And yeah, so no, I'm not going to build up everything on my own, especially related to, I don't know, 230 volts. But I think that open source is the thing that can save us there, because open source can help us to take back the control of that device. It can help us take back our privacy, because we can, as developers, reverse engineer that closed protocols, and we can share our findings, and other developers then can build up on the data or on the findings we made. And I think that is the way to go, because not building your own devices is a thing. Using the very well-engineered devices that are out there, but just like, I don't know, cut the wire to the vendor and say, well, I paid for this device, I own it, I want to do with it whatever I want. And sometimes people say, yeah, but a lot of those devices have APIs. For example, the Philips Hue system has a nice API, but might be shocking, that API is just another UI instead of your iPhone app to control the lights. So it's like the same data that is sent to the vendor. So actually we need to cut the wire a bit earlier and cut it before the data actually reaches the Philips Hue bridge, so we need to control the bulbs directly, for example. So I say vendor APIs are fine. Hey, super that you got them, but they're not enough. So the first target back then, it was like Christmas 2 years ago, around Christmas, was the Homematic protocol, because it was the most or the widely used in Germany back then, and I had access to a lot of devices. Yeah, by the way, renting is more or less over. The Node part starts. Hey. So I made up a library. That one's called NodeHomeward, for example, because it deals with those Homematic products and the Bitcoast protocol. If you check it out on GitHub today, you will see that it's a long time since the last commit, and basically that's for a reason, because I found a thing, and about that thing I needed to talk with the vendor of that devices and that protocol, and well, there will be an update once that thing doesn't exist on the firmware of that devices anymore. So I hope you get what I'm talking about without actually talking about it. Yeah, so I brought a demo with me. Ha. Let's see if instant webcam does what it says. Come on. Instant webcam, that's not instant. And not a webcam right now. Huh? The IP address changed because I'm in the wrong network. Sorry, instant webcam. You're probably working instant, but I was instantly switching to another network. So, sorry. Need to wait 4 seconds until hello, Wi-Fi networks. Yeah, I'll just create another network. What the heck? Here we go. Yeah, same network. Let's give that instant webcam another try. Still says no Wi-Fi connection. Hello? Hello? Okay. Here we go. Come on, come on. Cross your fingers. Come on. No. Well, like, so let's just use, I have another idea. Let's just, pardon? It did get a new IP, but no, it was actually the same IP, sorry. So yeah, let's do this differently. I'm just going to do it that way. That's not really wireless. So I hope you recognize this little fellow. That's a simple Arduino, most simple configuration, because I've just attached one LED. And that is the NOcean switch, as said. So Arduino doesn't know about NOcean. NOcean doesn't know about Arduino. But I have some Node programs running in the back. That one's connected to the Arduino. That one actually takes commands from NOcean enabled devices, so also from that switch. And if I press the button, I can turn on and off the LED on the Arduino, even though the Arduino doesn't know about that switch, and that switch doesn't know about the Arduino. So it's just like simple bridged using HTTP as a protocol between those two node processes. So that's that one thing. But yeah, as said, I actually, and I'm just closing this because probably you can see that even from behind. I have a plug here that is a Bitcoast-enabled Homematic plug, and I'm basically using the library I wrote to do this. If it works, no, it doesn't. Ha. Oh, the bulb isn't. Would be? Yeah, that's the joy of hardware hacking. Probably just the process just died. Yeah. Can start it again. Yeah. It just died, the process, sorry. So I can now use the switch to turn on and off that light, especially if I'm not killing the process again, but yeah. So you see a lot of, well, let's say, gibberish data here, and I'm going to explain what this data actually means. So this is like the piece of data that the device sends or emits if it sends an event like, hey, I'm turned on, or hey, I'm turned off. And if we seduce the data, then we have the type of the event, or the type at first. So if there is an S, you say, if there were an S, it would be like sending a command. And that's actually a unique device ID. You can change, so it's not truly unique, because you can actually change that ID on the device. No idea what this stands for. This is a timestamp here. It actually took me a long time to figure out that this is a timestamp or what time it represents, because at first I thought, okay, that's probably some hexadecimal representation of a Unix timestamp or whatever, so counting on from 1970. No, to save some bytes in the transmission, they started counting on from the year 2000, not from 1970. And that actually, well, it saves some bytes. Great. But what is actually really interesting for us is the payload, because that is the actual data. And that piece of data is actually from a temperature and humidity sensor. And somewhere in there live the current temperature and humidity of the room. And my problem when reverse engineering the protocol was that the payload differed from every device. So even you had two different switches. One was also measuring the power consumption, and one was not. Or you had like a dimmable device that looked exactly the same, etc. But the semantics of the payload were different all the time. Plus, even like devices that nearly did the same thing, like measuring temperature, and another device that measured temperature and humidity, had totally different semantics in the payload. Don't know why. Also, this is a closed protocol, so there's no documentation I could dug up on the internet about how to, decipher that data here. So yeah. In the end, so that's more like an end product, I had to do stuff like this, so like stripping the payload, parsing it to an integer, for example, doing some weird tricks with bits, and yeah, in the end, ended up with temperature and humidity. Yeah, but it's like, how did I find out that I actually had to do this, for example, or that I had to slice the payload here to get the humidity? In the end, I cheated a bit, because I found the vendor firmware for their hub, for their smart home hub, and it was a file without an extension, and I just tried like adding a file extension named .zip, and hey, I could open it. Perfect. What was in it? It was a complete Linux, tiny Linux system, complete Linux file system, and somewhere below I found some XMLs, and actually it looked to me like those XMLs were quite close to the findings, or quite close to the data I had already identified with the timestamps and stuff. So they were actually describing the semantics of the payload, and it was some weird format with an XML with at index -7 you find something, and at index blah you find something, and you have to convert it to hexadecimal to make sense out of it. And some weird stuff, and I mean also XML, right? So, and also a lot of try and error was involved in getting that stuff to work then. But that was only like receiving data. I also wanted to send data, like to steer devices. And that's actually the code I've written to, well, turn on that plug. And this is like, you see down there, the command. And the action is the most interesting thing, because if the action is C8, it turns on. If the action is 00, the device turns off. And all that stuff around here is mostly ceremony for sending over those two characters. So yeah, I mean, that's all easy once you found out how to convert the data, and I'm not a computer science person. I actually I have a web design background, to be honest. And so I didn't know what a nibble was. So who here knows what a nibble is? It's half a byte. So I didn't know that. So I needed to learn all that stuff while I was like playing around with their protocols. And in the end, I had built a USB driver for that particular USB stick from that vendor that speaks that protocol, and also, I'd say, a parser for that protocol completely in Node.js, which I never thought I would do when I started writing JavaScript. And of course, I mean, it took me a long time to figure out how to do this, and there was lots of swearing involved, but I'd say in the end it was worth it, because then I had a way better feeling with all the devices in my home, because now I did know that they do not transmit data to somewhere, because there is no somewhere. There's just me being the master and controlling them. So practically, I'd say I'm again the owner of my own home, and nobody else is there and, well, sniffs for data. So, well, next steps, basically you could build up on that. It's not that reliable, as you've seen, but there's a lot of stuff that still is missing from commercial products, that is missing in this solution that you have in commercial products, like having a rule engine, have like actually things that react to sensors. So let's say the temperature drops below 15 degrees, and then turn on the heating. You need some kind of business rule engine or whatever to handle that. Well, at the moment, I'm handling this with an 800-line JavaScript file, where I just had like, if temperature is lower than, do this, and stuff like that. But that's like not really enterprisey, I'd say. And usually a lot of people ask me, Sebastian, hey, why the heck did you use JavaScript? I mean, first of all, that's like the language I feel comfortable in the most. Also, the open source community is wonderful in JavaScript land. It's pretty good for prototyping. It's not like in Java, where I have to type like the abstract impl button click factory whatever. No, I just could like write click. And the JavaScript community is also big enough to make this happen, not for one protocol, but for a lot of devices. And you see that if you go on NPM and you type in, yeah, I want to have an adapter for the InOcean protocol, I want to have an adapter for the Z-Wave protocol, I want to have an adapter for this or that Bluetooth device, you get actually a lot of modules that do just that. And a JavaScript community is, when it comes down to that hardware stuff, one of the most prolific communities I've seen, even not the most. Also, I mean, like in Germany we have a saying, you can poison pigeons with that term, but nowadays JavaScript is isomorphic. So basically, for example, you could run the same rule engine if you had one in the browser and on the server, and prepare some rules while you're offline, or use the new Bluetooth APIs that are in Chrome when you're just connected to local Bluetooth devices and lost connection to the server, something like that. And in the end, it's the Internet of Things, right? And what is more Internet than JavaScript? Well, maybe HTML and CSS, but hey, if in terms of programming languages, JavaScript and Internet, that's the thing, not an iPhone app. And also, last but not least, when I first encountered Node, people were telling me Node is extremely good with dealing with networks of networks and also asynchronous data. And what is this, what I have here? At the moment, I have 2 different networks, let's say 3 different networks, also asynchronous data, like or evented data, like when I turn this on, I get data sent back to my system because the plug tells me, hey, I'm turned on. And yeah, I mean, like, this is exactly what Node.js is good with. And therefore, that's why I have written it in JavaScript. And yes, that was the end. Thank you. If you have questions, ask me, write me.